One last topic to talk about the spinal cord before we move on to chapter 14 and all that wonderfulness about the central nervous system, the brain, and all that wonderfulness. This is actually quite interesting. This is a very interesting topic about neuroanatomy. It explains a lot about the connection between the spinal cord, the brain, and a lot of how our body works and interacts with one another. It's like the peak of what goes on inside the brain. It's really neat stuff. So first off, since I already have this pulled up, I want to point out that this blue one is referring to, again, that posterior nerve, which you should remember, hopefully, after the past two videos, that it's referring to a sensory nerve, while the one that's anterior is referring to the motor neuron. We do have this chance of being an interneuron, so a spinal reflex never really leaves the spinal cord or goes back up to the brain. There is a signal going up to the brain, but the initial reflex, the initial response to any type of painful or dangerous stimuli or autonomic stimuli often only requires just going to the spinal cord and back. So the terms you would want to know: first is a stimuli, followed by the sensory neuron, followed by an interneuron possibly, followed by a motor neuron, which then goes to an effector, where it affects what it does. With that, let's go ahead and talk about it. Again, that middle spot, this gray matter, is that neural body. We're going to find a lot of neural bodies that are involved with the motor neuron, with the reflex, and other portions, bits and pieces of those neurons. And I had mentioned it earlier. I wanted to make certain I hit this. It does have a lot to, these reflexes do have a lot to do with the autonomic systems, or things that just sort of carry on by themselves, with digestion, with minimal intervention from your brain, the heart rate having minimal intervention with your brain rather than nothing more than just telling it to speed up or slow down, and then other autonomic functions, which we will talk about in chapter 15. So bonus of having it just go to the spinal column is it's like 15 to 30 milliseconds, while just blinking your eye takes 10 times that, 150, 100 milliseconds. It also explains, for those of you that are gamers out there, why you don't want an internet slower than 100 milliseconds, because you're basically giving your opponent, if it's an opponent player versus player type of situation, you're basically giving your opponent a chance to process the information before you even realize they are there. It's quite unfair and unfun. Some vocabulary terms that we do need to talk about are these 5 right here. Ipsilateral. Lateral a portion of this name should sound familiar. Lateral meaning side. So there's lateral. I am referring to sides of the body. Ips usually means, or I shouldn't say usually, it means same. It is ipsilateral. So whatever happens on one side, like there's a stimulus coming in from one side of the body, like you stub your toe and you pull it away, that means that the response is going to come back to the same side of that body. So for instance, you stick your hand on a burner, you're not going to pull away the other hand and leave the other hand, the original hand, on the burner. That's completely dumb. You're going to get the sense that you just touched something extremely hot, and there's a motor neuron saying, hey, move, stupid, and you move your hand. Contralateral is when you actually have that signal across the other side of the body. So you, if I were to use my last example of putting your hand on the burner, or it would be actually moving the other hand. Probably a more appropriate example would be a dog bites your finger, so you pull away your hand, and at the same time you bring the other hand forward to knock it down, type of thing, of a strange dog. I know that sounds like an inappropriate example. I do apologize, but it is a potential example of a primitive reflex of fighting back. Now these next two terms, monosynaptic, polysynaptic, should sound pretty familiar. Mono meaning one, poly meaning many. This is actually referring, the synapse should sound somewhat familiar from the chapter in which we discussed neuroanatomy and histology and what a neuron looks like, with that synapse referring to whether or not you have 1, 2, 3, or 4 neurons being involved. So poly meaning that you have multiple neurons, monosynaptic referring that you have one synapse. Now reciprocal innervation, perhaps it could be better worded and phrased here. It's referring to two muscle groups. It can be on the same side of the body. Let's say you're talking about the same leg. You could have your quadriceps and your hamstrings working together to alleviate something that could be detrimental, like you overstretching that muscle. So the quadriceps, so your antagonist, your hamstrings, might work to try and correct that by either relaxing or flexing depending upon the situation. Or and vice versa, your quadriceps working to help alleviate issues that you have with your hamstrings. Now let's begin. We're going to talk about just a few examples of reflexes. This one's the stretch reflex. What happens is with this, you're going to notice that you have a little reflex hammer. I'm going to just keep it as the name as the reflex hammer, hitting that tendon. What that doctor is checking is to see how well your muscle responds to you get your tendon, your muscle stretching, your tendon stretching. Primarily, if you notice here, it's innervating the muscle fibers itself, so it's going to be referring to the muscle stretching itself. Sensory says, hey, muscles are getting stretched, let's go ahead and head back to the spinal cord. That signal is sent to the brain, but most importantly, for a quick save, you're going to go ahead and have that reciprocal innervation come along. One positive saying, hey, it's time to move and prevent that overstretching. If you overstretch, you're going to rip that muscle. We don't want that, so you need to contract. With that reciprocal innervation saying, hey, antagonistic muscle, we don't need this pulling any further. Why don't you relax? That is the stretch reflex. You could have a tendon reflex in which you have something going on with the tension in that tendon, and it's getting too much for that tendon. And if it gets too much, you're going to start ripping that tendon, and that's a very, very, very bad thing because tendons do not grow very quickly back. So that sensor, that nociceptor, the OWI receptor, that stretch receptor, all those receptors, we'll talk about the different types of receptors in 15 or 16, but will be sent. It'll go ahead and say, hey, there's something going on. Goes to the spinal cord, signal again is getting sent to the brain, but the most important thing to help rescue an issue is first shutting off that quadriceps muscle, saying, hey, this thing is being overstressed, relax, with the antagonist muscle helping out by pulling it and relieving the pressure that is going on right here. A flexor withdrawal is, they're showing the leg again. It's a nice little thing to segue into for the next one, but I'm going to use my hand, the hot plate thing again. You're going to put your hand on, you accidentally stick your hand on a hot plate and you go, aye, it burns the flesh. Well, that's just that's a withdrawal. You're pulling your hand away from the hot plate and avoiding extra damage and extra pain that comes with touching something it's obscenely hot. Now, if we go back to their example, you see that this gentleman has now stepped on a nail, or at least kicked a nail, it looks like. Not a pleasant experience, obviously, but you are withdrawing from it so you don't insert that nail any further, or you don't do something that hurts it even further. And this is a withdrawal reflex. When it is a leg reflex, when it is something when you are standing up, you do not want to fall down because you have decided to withdraw your foot. You need your other side of your body to compensate for you releasing pressure on the OWI foot. And that is called a crossed-extensor reflex. It's where you get an owie on your right leg and your left leg coming along to restabilize because you don't want to fall down. Falling down gives more owie. So you're going to catch it with the other foot. You get an owie. Owie sends up, says, "Oh goodness, we got owie boo boo. Let's make certain we don't fall down." Sends information out to the other leg to catch it while this leg is doing the withdrawal. So the cross extensor is catching you from falling down. So I do have a video here of the home alone. If you have that, I obviously can't show you this particular scene because I'm recording and I don't want to have copyright issues and sued and all that stuff. So watch this when you get a chance, and you can watch to see if the actor or this, I can't remember the thief's name, has really any neurological issues. With a couple of questions. Like for instance, I'm going to go ahead and pause right here just for a second. Go ahead and pause here, watch the video, because I'm going to be asking and pointing out what I see is wrong and that this gentleman probably should have gone and checked his neurologist a while ago. So 3, 2, 1, here we go. So problem with this is that he has just stepped on a nail. And if you remember, a reflex is not taking more than 10 or not very many milliseconds. It's in the double digits at most, 25 to 35, maybe 50 milliseconds to react and stop. And we should have seen a crossed-extensor reflex. All you see is the guy looking down at his foot and going back up and starting to scream. So that's why he fell down, go boom. Now, there are a couple of reasons why your reflexes would be off, or perhaps, and if the reflexes are off, you got nerve damage. If your reflexes are overly compensating or overly exaggerating, like for instance, I don't know if you've ever watched an episode of a cartoon where a doctor just barely taps the tendon of one of the cartoon protagonists or antagonists, and then the leg kicks up and the doctor gets kicked and the doctor goes flying through a wall or two. That would be me questioning whether or not there is something wrong with the patient, with the protagonist, because that is an over exaggeration. If there is something wrong with the spinal cord, part of the brain's job is to stop or inhibit unnecessary movement. So if it's damaged, that dampener is going to not be there, so you're going to get like an over-exaggeration. If it's a nerve damage, you're not going to see any movement whatsoever because the reflex arc is broken. Now there's a bunch of ways you can get owies and boo-boos, whether it be a stroke, whether it be trauma, whether it be some type of severance or what have you. We're going to talk. So there's 4 different types that you will care about, not only for AMP2, but you're also going to care about for the ATI test if we're still taking that, and also for pathophysiology. They are monoplegia, paraplegia, hemiplegia, and quadriplegia. Monoplegia, these 2 should sound pretty easy to figure out. Mono means 1, quadra means 4. So monoplegia means weakness or no response from one limb. Quadriplegia means from all 4 limbs. Paraplegia, if somebody is a paraplegic, it means that their legs are not working, or both same type of limb is not working. So 99% of the time, well, I shouldn't give an exact number because I'm not as super familiar with the number or the statistics. But the vast majority of the times it's referring to a leg issue. Hemiplegia is a one-sided issue, whether it be the left side of the body or the right side of the body. Usually that's accompanying a stroke. So it could be one arm, one leg on one side or the other. Now, I did mention it, the reflexes still work if it's something that has damaged the spinal cord. It's just that they are over-exaggerated reflexes. You can also see something else sometimes manifest. So for instance, there's a Babinski sign. If you look over here on signal B, this is also from Marlon Serrano, I took this from Pinterest. You will see in babies when you draw the end of your reflex hammer up around the arch, not the arch, the probably shouldn't have drawn that it's going through the arch. It actually starts at the heel. You follow the pad of the foot that makes contact with the floor, and then you go to the big toe. When you do that in a baby, in an infant, less than a year old, the big toe is going to go up and the toes are going to fan out or splay out. In an adult, you'll see it all come down. Now, or you can also see this Babinski sign if you have damage to your your spinal cord. Because your spinal cord has a lot to do with inhibiting these exaggerated or this extensor type of thing. Your spinal cord and your brain coordinate appropriately to create that downward fashion. With that, I also have one more video to help really point these things out. I would highly recommend, if you have these downloaded, to go ahead and check this out. This was a very well done video of a clinical case from the Heart and Stroke in Scotland. Really interesting watch. It really demonstrates an exaggeration. I would point out now, because I'm probably not going to be around while you're watching this, that the right side is the one that's affected on this patient. So watch for the reflexes. The right side, which means hemiplegia. Right? Right. Excellent. Have yourselves a wonderful day.